Okay, so last class you saw area moment of inertia about inclined axis. So just let us recapitulate before we proceed for more circle. Okay, just see what we have done earlier. So this is moment of inertia about x-axis and y-axis that we already know. Okay, we wanted to find out moment of inertia about an axis which is inclined by an angle theta to the major axis, maybe x-axis. Okay, so that is what we want to do. Okay, so we started with a small elemental area, and the same way we integrated, and what we got, let us directly go to the result. So this was already known. We started with this assumption. Okay, Ix is equal to y square dA, Iy is equal to x square dA, and Ixy. This is just the definition part of it. Okay, so the rotated frame axis can be given like this, and we saw, yes, Ix prime, Iy prime, and Ix prime y prime, that is product moment of inertia about this inclined axis would be something like this. So after integrating, we saw it came using these terms, it came something like this. Okay, so yes, so this is Ix. You saw there is some difference. It is Ix, when you take it goes plus, and over here it is minus. These are few things which are to be noticed. And similarly Iy, when you take, it is over here it is minus and here it is plus. So if I write Ixy, x and y together, we can write it over here as plus minus and here as minus plus. Okay, so that is a compact notation, we can do it. But what exactly are these? What exactly are these? Can does it have any physical significance also? Is there any angle which is there which is given by 2 theta in a physical system? No. Physical system, it is theta, whereas in this geometrical interpretation it is algebraic expression, this is 2 theta. Okay, but yes, looking closely, these are basically parametric equation of a circle, parametric equation of a circle with radii and center which is offset from the origin O by a distance. We'll see what it is. Okay, so it gives a parametric equation of a circle. Okay, so yes, now we will go ahead. Yes, these were some of the things, some interpretation that also we saw last class. Okay, so this is your parametric equation of circle. This is maximum point. Okay, maximum moment of inertia is at an angle theta m. Okay, at an angle theta m, which is given by this. Okay, theta is equal to theta m. You get to see a maximum moment of inertia for Ix dash, and if Ix dash is maximum, this turns out to be the minimum one. So if one of the axis it is maximum, other orthogonal axis it is minimum. Okay, so that is why it is pi. Okay, so that is what is there. So if you express this as 2m plus pi, so effectively it comes out to be a difference of pi by 2. That also we will see today. Okay, so these are some of the expression. Okay, by doing some substitution, and we can also obtain something like this for maximum and minimum. If you substitute these values to the original equation of moment of inertia, that was these, okay, you can quickly obtain something like this. So what are these actually? Okay, yes, it is good to have these in hand, algebraic expression in hand, if you want if you want to do some moment of inertia of an object at any arbitrary angle theta. Okay, definitely this gives you at a minimum and maximum value of that theta, for which theta becomes maximum, I becomes maximum and minimum. Okay, so let us see what exactly is Mohr circle. Mohr circle is exactly a representation, geometrical representation of what we saw using those parametric equations. Okay, so yes, now what type of circle is this? Where is the center? how much is the radii, those things we will talk about now. Okay, so these were the equations that we obtained just now. Okay, so now let us take this axis as principal moment of inertia axis. Okay, it will either show Ix or it will show Iy. Okay, and perpendicular to this gives you a product moment of inertia axis, which will always show Ixy. That means product moment of inertia will come here. Okay, so Ix prime, y prime will definitely come here, Ix prime and y prime will also come here. Okay, so this is an axis to show moment of inertia, principal moment of inertia. Okay, and this is the axis which shows product moment of inertia. Okay, so now if you form a equation, if these equations can be put along these axes, it forms a circle which is given like this, and mind it, yes, this is what Ix plus Iy. So the extreme ends, if this is Ix, this will be Iy. Okay, if this is Ix, this will be Iy. So exactly opposite to that will be Iy. So if you take Ix plus Iy by 2, Ix plus Iy by 2, if this is Ix, that means this point basically, because you know Ix and Iy is shown along x axis. So Ix and Iy, this will be your point for Iy and Ix will come here. So this plus this by 2 will effectively give me the center of that circle along horizontal axis. Hope this is obtained. This is quite clear. Yes, okay. So yes, again next term see it carefully as well. Ix minus Iy by 2. Okay, Ix minus Iy by 2. So this effectively gives you this distance, is it not? It is giving you this distance. Very good. Okay, and you also have 2 theta, that is an angle. 2 theta, that is an angle. It can be this angle, it can be an angle from an angle also. If this is already at a theta, this can be another theta. Okay, so this is this angle. Okay, it is this angle. Okay, that is shown here as 2 theta. Okay, and Ixy also as sine 2 theta. So this exactly shows the parametric equation of circle. Independently they are denoted. So dependent variable and independent variables are there definitely. Okay, so Ix and Iy are 2 points along this horizontal axis, and Ixy is a point which is along vertical axis. Okay, so this is how it is expressed. Okay, now let us see more closely into it. So this also holds true. Something that we have obtained, this we know is giving you J0 or moment of inertia Iz. Hope you got it already earlier. Okay, so Iz or J0 as per perpendicular axis theorem. So you see this is also holding true in this case also. In case of this circle also this holds true. So Ix dash plus Iy dash, this plus this dropped onto this, Ix dash and Iy dash should be equal to Ix plus Iy. It can be any other 2 points. So again drop these, sum of these should give you a constant value that is equal to J0. So this holds true again. Okay, now squaring and adding these equations, what it exactly gives me, or by eliminating these terms cos theta, tan theta. Okay, and this gives me this term directly. So see what it is actually. So Ix plus Iy by 2, Ix plus Iy by 2 basically is this point, is it not? It is this point. So Ix, let us see if it is this point. So it is a perpendicular drop on that. So Ix minus this point is effectively this distance. So this distance plus this vertical distance, that is this, squaring gives me radii. Okay, that gives me the radius. Okay, and this also is exactly the same. Okay, so that is again the same. So Ix, if you take it otherwise, okay, so this is your Iy. So Ix minus Iy by 2 again is this distance, is it not? This also is this. Okay, and again you may have Ixy square. So this time it is not Ix prime y prime. Okay, all because all is taken along x and y. So this also will be xy. So you see this effectively is giving you radius and both are same. Okay, so setting I average, that is Ix plus Iy by 2 is basically I average is this point, and radii is this term, this term. Hope you understand that. So this is your radius of this Mohr circle. This circle is given known as Mohr circle. Okay, and I average is this point. This is the radius. So this effective is the equation of that Mohr circle. Okay, so I average minus Ix dash square whole square plus Ixy prime Ix prime y prime whole square is equal to radius square. So this is the equation of that circle. Okay, so if this is the equation of that circle, okay, so this effectively is a circle with a center at this point. So it is shifted by along x axis by distance given by I average. Okay, so this is how, this is a geometrical interpretation of that circle. Okay, and maximum and minimum, how much will that be? So I average plus the radii should give me the maximum I, and I average minus radii gives me the minimum I, is it not? So these are the two extreme points where you see the maximum and the minimum value of moment of inertia. Okay, but yes, you see angle between them should be 90 degrees, but over here it is 180 degree. Okay, over here it is 180 degree. So effectively from I max to I min in this circle is at 180 degree, that is at a pi gap. But effectively if you see any object, so minimum and maximum is at 90 degrees. Okay, if this is maximum about this, so this should be I minimum. Okay, so that is how it is. So this circle represents any point, any axis about which moment of inertia can be found out with this, but this time it is 2 theta. Oh, so if you want to find out at an angle theta, so you have to clearly draw a line which is at an angle 2 theta, and this is your maximum and this is your minimum moment of inertia at that particular angle. If you take that, so major axes, okay, major maximum and minimum moment of inertia, two orthogonal moment of inertia would be given by point over here, point over here. If you drop them perpendicularly downwards, it should be like this, and this vertical one effectively gives you product moment of inertia. Got it? So this is maximum, this is minimum at an angle theta, and this vertical one will show you the product moment of inertia at that angle theta. Okay, so this is how this circle can be used to find out moment of inertia of any body or any area about an inclined axis, as well as product moment of inertia about that inclined axis. So what are the points? Mind it, this is point this, and point this and point this. These 2 points are taken from this. Okay, this. Okay, so this becomes your Ix prime, this becomes your Iy prime, that is the new axis, and vertical one gives you Ix prime y prime, that is product moment of inertia. Anyway, without making it further dirty, let us move ahead and see how this moment of inertia again can be used given a moment of inertia about an axis which is inclined at an angle theta. Okay. So yes, you saw this circle gave you a situation when you see the principal moment of inertia. Okay, that is the maximum one and the minimum one. This will be the maximum and this will be the minimum one. Okay, whereas these two, this point and this point, are definitely not the maximum and the minimum one, but yes, it is about its own x-axis and about y-axis, and this is product moment of inertia about that. So if at all, and how much was this angle? This was 2 theta taken in this figure, but actually it is at an angle theta for the object. Okay, for the area it is at a theta, so you have to take 2 theta and get these values. This can be geometrically obtained as well. Okay, yes. So going to next. Yes, now why this is 2 theta m? You know, given at an angle which is, if these two values are given, okay, moment of inertia about two orthogonal axes are given. Okay, so you can quickly plot them over here and here. Okay, so if you draw a straight line segment, okay, so this is the line AB line. If you draw at an angle 2 theta m, what is 2 theta m? So basically this is, this horizontal line gives you what? It gives you the maximum and minimum value of this moment of inertia, is it not? So these were given. If you draw a horizontal line, measure this angle theta, okay, this angle theta, this is, what is this? This is effectively 2 times of theta m. So this will directly give you the angle from the given location, okay, where you can expect to have maximum moment of inertia. Got it? Where you can expect to see the maximum moment of inertia. Okay, so these are the points where you can see the maximum moment of inertia, or I max and I min will be lying here. Okay, so this is the point, it is done. Now if I want to find out another moment of inertia which is at a location x prime and y prime from the given location, from this location, okay, from this, if you want to find out the moment of inertia x prime and y prime, okay, about a new thing, then you again take another angle 2 theta. If you want to find out at an angle theta, so this will be 2 theta. Get these 2 points, drop them here, and you can find out the moment of inertia at new position, that is at an angle theta, from the given location, got it? So this will give you I x prime and this will be I y prime. This was I x and I y, got it? This was I max and I min, got it? So this is I max, I min, I max, I min. This is I x, I y. This is at a new location, I x prime, I y prime. Okay, so these are different interpretation, and these are different advantages of having a geometrical thing, so that you can directly, by measuring the location or plotting this circle on a graph paper, you can quickly or at least obtain some values. Okay, so let us see if we can do it using algebraic and trigonometric expression also, the way we were doing it. Okay, so these were the equation. Ix and Iy were given, this and this points are given. Okay, so you can quickly use or your original equation. So these were the plus minus, minus plus, if you remember. So these are the original equation that you have obtained. So using that also you can get the values. Okay, you can get Ix prime, you can get Iy prime, and also the product moment of inertia. Okay, so this is the geometrical interval and this is your maximum thing. So now what are the steps for this? Steps for finding I max and I min, and ix prime, y prime and product at any angle theta. What is given? This is given. Okay. So how will you go for it? So choose the horizontal axis, moment of inertia. Horizontal axis will show moment of inertia, that means Ix and Iy can be shown here. Vertical axis will show as principal inertia, okay, principal moment of inertia, okay. So that is along this direction, okay. This is how you will start, okay. What is given? This and this value is given, okay. These are given, got it? These are given, okay. And that is something that I want to do is this. Okay, so this is first. Next step will be known point. Known point is point x. How will you get this point? Plot ix, which was given, and ixy, which is also given. So that means this and this is given. So you can quickly plot this point. What is this point? It is ix and ixy. Got it? So this you can quickly draw. Again, what will be this point? It will be a mirror of that. Only y coordinate will be negative, x will remain as it is. Okay, so it will be iy. This is how much? This point. This is iy. This coordinate is iy. That is already known. It is given. Ix, iy and ixy is given. And this will be minus of ixy. So if this is plus, you know this is a circle, this has to be minus of ixy. So you got these 2 points, x and y. These 2 points are known. Okay. Okay. Now draw the circle with diameter as xy. Diameter as xy. How do you know where is the center? So you have already taken the horizontal axis, wherever it intersects with this 2 point, if you join them together. So if you join these 2 points together, wherever it intersects the horizontal axis should give you the center point. Okay, now you can draw the circle. Take 50% of this, definitely you can draw this circle, is it not? So this circle you can draw. Okay, moving next. So angle 2 theta m, angle 2 theta m to the horizontal basically will give you, if you circle wherever it intersects to this horizontal line, these two are the points. Okay, these should be I max, that is the maximum moment of inertia, and minimum moment of inertia over here. So this should this effectively gives me the maximum point and this is the minimum point. So this is the angle from the given angle 2 theta m, that means whatever you measure, let us say you got 30 degree over here, so that means this is equal to 30 degree. So theta m, that is 15 degree from the given position. If you turn, you will get the position where you see the maximum moment of inertia, and 90 degree from that you should get minimum moment of inertia, is it not? Okay, so yes, so this is I max and I min. You got it? Okay. Now find out to find x prime and y prime, you now go in the opposite direction. Why opposite? It will be given in the question itself. If you have to turn to this direction or this direction, towards the maximum one or towards the minimum one. Okay. So if at all it is given, normally if it is clockwise rotation, counterclockwise is positive. If nothing is given, to take counterclockwise, it is the positive angle. So if at all it is asked, find out the moment of inertia at an angle theta from the given position, you have to rotate counterclockwise. So take like this. Okay, so if this was there, so you have to do this. So because theta is asked, you have to do 2 theta over here. Okay, 2 theta over here. So that will give you a new location. If it is asked to rotate at 15 degree and let me know x prime y prime, you have to rotate over here by 30 degrees. Got it? Remember this. So this is your 2 theta. Again, passing through the center, draw a straight line that intersects the circle at these 2 points. That should immediately give you the points x prime and y prime. Got it? So this is the step. Something is given, something has to be found out. Basically, what all things that you can find out, given ix, iy, product moment of inertia, ixy, you can find out the location of maximum and minimum moment of inertia. Okay, location in terms of angle theta m. Okay, and their values also you can obtain. Okay, again you can get to a new angle theta and find out the moment of inertia, product moment of inertia and moment of inertia. Got it? So this is how you can draw a Mohr circle and get all those values. Okay. So I hope this is quite clear so far. That's all.